Well, I think now it's time to get started on the front end and building the deploy script so we can actually get this started on chain. And so in this repository structure, well, actually before I do that, I'm going to just for good good hygiene to commit things as you go. So we are going to add everything. We're going to git status. We see that we have these three files that we want to be committed. Git commit, and put a message of adding contracts. There we go. So we're going to create a new folder and we're going to call it Frontend. And now we're going to, I personally prefer the setup with Vite. So we're going to use this Vite getting started. And the links for these are going to be in the description. The easiest way to get started on Vite is to use this npm create vite at latest command, which is going to do the template and make sure that we're in this sweetplace dot front end. Make sure that we're in this sweetplace front ends directory, and we're going to go ahead and run that command. Project name. Let's make this sweetplace front end. We want this to be in React. We do want TypeScript, but we don't want SWC because that's experimental. And let's make sure that it did things correctly. Yeah, so one thing that I did not think of is that when you run that command, it creates a new folder, but actually we wanted all of this just in the front end folder. So we're going to fix that by moving the sweetplace front end to be like, sweetplace front end, and we want it to be in the sweetplace, just call it temporary name, sweetplace old. Oops, well I misspelled that, but it doesn't matter. And now it got rid of everything in this front end, so we can just go ahead and delete this front end, do it from terminal, and then now we rename this to front end. And then this is the folder structure that I really want. So now that we're here, we can do a couple bookkeeping things. Look at package.json, change the version if you want to, add any licenses you want to. This looks good to start with though. So we're gonna go ahead and make sure it works. We're going to cd, or we're already CD'd in front end, perfect. ls, that is strange. Not sure why that happened, but we're gonna fix it by leaving and re-entering the front end folder. Oh, probably because I renamed it and it got weird there. That's fine. So we're gonna run npm run dev to get the. Oh, that's because we need to install everything first, and then the development. We want to run this vite command through the React scripts, or through the npm package scripts, and that only works after you run this npm install command. So now that everything's installed, we can do npm run dev, and it will give us this URL that we can actually control click to open. And this is just what comes in default by Vite and React, and this is exactly what we want. So now let's do some other things. Go back to our package.json, close out of this, we don't need that for now. One thing that we want to do is we want to add a couple things. We want to add a .env file. We want to install, so let's install this package, install .config. And one thing is npm I and npm install are exactly the same command. They're interchangeable. I sometimes use one, sometimes use the other. Really doesn't matter which one you use. So we just installed .config. What this is a package that makes it very easy to do these .env files. So a lot of the times when you're doing one of these applications and you want to have your code open source, you have a file called .env, and this is where you put the secrets that you don't want the world to see, but you need locally in kind of a structured format, so that later down the line when we implement a deploy script, we're going to keep our private key in this, so that we can have our easily accessible private key and use it, but the world won't be able to see it when it comes time to deploy this to GitHub or whatever other repo of choice. And it's also really good practice to have we want to implement this. We want to add this env.example. And the difference here is that this is going to have the structure. So like, let's say that we want, so this is going to have the structure. So we can have the like when somebody comes and actually clones our repo, they're going to clone this .env.example. They won't clone the .env, and then what they're going to do is they're going to rename the env.example to the .env, and then it's going to be good to go. So we want to implement this as like a private key equals some exclamation points, and for now, this is supposed to be a template for what the .env is supposed to look like. So we're just going to copy paste that. So notice here too that it says the .env is untracked, and again, that's not what we want. We want to block that from being committed to source. So we're going to go ahead and go to this .getignore and press the .env, and just to make extra sure when we run, we're going to add everything. Git add .get status. We're going to see that in here there's env example is committed, but there's no .env. Notice here too, there's two .getignores. It's totally okay to have multiple getignores. It's just that the rules from here are going to be relative to this folder only, and the rules for this are going to be relative to the whole thing, because this is in the root directory, but this is in the front end. So the rules for here are going to apply for the front end, but not to like contracts. And now that I think about it, I think it's actually a good idea to put this in contracts, because this has a good just to keep it consistent, and then we can remove, since the root of this is no longer the root of the folder, we're just going to put build, and then it's the same as it was before, but now that the folder structure looks a little bit prettier. Git status, and let's just add everything. Forget measuring. Let's commit everything. Good practice. Initialized delete front end. So now that we have this .env set up, we're going to want to put the actual secret in here. And again, we have move stores our secrets in this .sui. Sui move stores the secrets in this .sui/sui.config and then the sui.keystore. And this string, we're going to want to copy paste that. Whoops, that's not what I wanted. Let's just do it. Right click, copy, and then paste. And now it's time to set up our deploy scripts. In other projects, they do the deploy scripts in this contracts folder and just make it a JavaScript. But personally, I like to have my deploy scripts be in TypeScript. Just makes it a little bit easier to develop. So we're going to create this folder in Frontend, and we're going to call it scripts. And we're going to put a new file there and call it deploy.ts. So now that we have this simple test script, let's go ahead and add it to package.json so we can run it. And we're going to rely on this tool called npm tsx. Yes, TypeScript execute. This is because by default the way that we're compiling, I guess this is probably further into the JavaScript build step than we really want to get into. But when it comes to build, we're using this. This stands for TypeScript compiler, and this is what TypeScript ships with. It comes from this package, just a regular TypeScript package, and that's what converts the TypeScript into JavaScript that the browser can use. But we're just trying to run TypeScript directly in like kind of a node style, where we're just running a script. We don't care about the compilation of JavaScript. And for that's why we use this tsx command. So we're going to install it via this npm install save dev tsx. We're using the save dev command because this is a developer dependency. It's stored in this dev dependencies right here, this tsx. And what this means, it signifies to npm that when TypeScript builds this source, when it builds the React front end into JavaScript, that it doesn't need to include like all of these packages because they're dev dependencies, so they're only needed when it comes time to develop things. They aren't actually necessary to ship to the end user. And with that, we're also going to add the script deploy, and this is going to be tsx scripts deploy.ts. And verify this works, we're going to do npm run deploy. And out comes our hello world. And now since this is a TypeScript file, we can do things like, have types. We do const x, which we want it to be a number. It's like say 3. This all works the same way. Everything works great. So now that we know that the deploy script works with TypeScript, let's start getting this set up. And the first thing is I realized actually that I had you install the wrong package. I had you install .config when in reality what you should be installing is .env. So let's just go ahead and uninstall that. Install .config, npm, did I mistype it? Uninstall .config, and then npm i.env. And then once we have that, we get that set up in the script by just importing .env/config. No need to import anything specific from that. It'll just work when we run when we just run the import. And then it will recognize that process.env.private key. And then it will recognize on this process.env this private key will exist because we set the private key to be a value in this .env. You could also set other things, and they would just appear as like a different string on this process.env. And we also have this issue where it cannot find the name process, and it tells us to run this command. So we're just going to go ahead and run it. C, Control V, and then fixes the issue. So then we can do npm run deploy. Yeah, not entirely sure why it doesn't immediately resolve that, but we can just close and open deploy script, and then it's possible that this priv key could be undefined. We want to make sure that it is defined. So we will just print some, if not priv key, if priv key is undefined, then we'll just print some console.log error. We'll print some error. Print error. And say helpful error message, private key not set in .env. And then we want to do console.exit and give it a status code of 1. Any exit code, or it's not console.exit, it's process.exit. And so now that we have the private key stored in a variable, we need to create a key pair. We need to get the public key, and we need to get into a format where we can actually start to sign transactions and do RPC requests. And we're going to use this ed2551919 key pair utility, and we're going to have to import that from import ed25519 key pair from Mistin/Sui.js, which is the package we just installed, and it's under key pairs ed25519. Now we have this variable. We can do from secret key, and we need to pass this. We need to in from this from secret to key. It expects this uint8 array. But the problem is we don't have a uint8 array that represents the private key. We only have the string. And so Mistin also gives us this utility that's really useful for that. It's called from base64 or from b64, and that's imported from Mistin Labs, so Sui.js, utils, and then we wrap the private key into the string into the function. 64 priv key, and we're going to do this .slice one. Whenever there's the public key, whenever you have this private key string, the private key string, there's always the first byte that tells you which specific format it's in. For example, there's the ed25519 format. There's also like the step, these two, which are other alternative formats. And the first byte of the result of this from B64 is going to be the determinant, which can tell you, which variant of crypto we're using. So this slice command, what this does is it cuts off the first byte, and then we just get the rest of the private key, which is what we need. And if you don't do that, this will not work. And we want to set that, we want to assign that to a variable. Key pair equals that. And now that we want the key pair, we need to actually run the. So we're also going to get the client. client equals new SWE client. I wonder if this time, no, we still need to manually import it. So SWE client, and we're going to import the SWE client from, just copy paste that, SWE client, utils. Instead of utils, we're going to import it from client. And this requires a RPC. So this is the URL, or an object with the settings where we set the URL of the RPC. So in our case, this is going to be the fullnode.devnet.swe.io, and it's, I guess they ask us to use the 443 port. So this is going to change depending on which version you want to deploy, and I would actually recommend, it's probably a pretty good idea to put this URL into the .env, because if you're using a node provider like a Suinami that requires some kind of like key thing, right? You don't want to put your key to your Suinami inside this, because this gets committed to source. You want to put that in .env. And also, I'm not entirely sure what the plans are for these public full nodes, if they're going to remain online for a while, if they're not. So it's entirely possible that by the time you watch this video that these are not available and you have to get your own full node access. So now that we have the client, we need to build the move code, and then we need to deploy it to chain. And we're gonna use we're gonna get the path to where we want to run the command to build, and we're gonna do that. So const path to contracts equals path.join. Well, let's start from here. So the first thing is that with this specific config in Node.js, the way that you get the current folder is use this thing called import.meta.url. So this gives you the full path to where the file is that we're currently in. We don't want the full path. We want the directory name of the full path, dir name, and this is going to be a function. However, it is not defined, so we need to import it from path, and we're going to do that. Dir name from path. And path is a default library that Node.js gives you. So now that we have the directory name, note that that's going to put us in the scripts. So we have to go back one, and then we have to go back one, and then we have to go forward into contracts, and that's where we're gonna need to run that command that builds. And so we're gonna do that. We're gonna accomplish that by doing path.join. Again, back one, and then forward into contracts. And now it's time to actually run the command. And we're going to do this with this tool called exec sync. This comes from child process, which also, again, is something that Node.js gives you. And so the command that specifically we want to run is swe move build dump bytecode as base 64 path, and we're actually going to make this, instead of the double quotes like I did, we're going to make this sync. We're going to make this grave, which is the key to the left of the 1 on your keyboard. And what this lets us do, it's called a template literal. What this lets us do is we can use a variable inside of the string using this special $sign syntax. And then we're going to put the path to contracts path to contracts. This is the command that we want to run, and then it also expects a second options, and we're just going to set the encoding to be UTF-8. And then this is going to give us some output. It's going to print to standard out, and then this exec sync automatically for us, it's going to return as a string whatever the output that running this command is going to be. And so that's why next we need to do json.parse to parse it from a JSON string into an object that we can use. And specifically, we're going to destructure that. This resulting JSON is going to have two keys. It is two keys that point to values that we care about, and that's going to be modules and dependencies. Actually, maybe it'd be useful for me to just run this, and so you can see what this gives you. Console.log. Just make sure that everything works so far. It's giving us an error. Why is that? Yeah, we need another one of those. npm run deploy. What happens? Well, we got this error. It says no such file directory, and I suspect it's because something's up with the path to contracts. So let's just double check that. So log path to contracts, and make sure that it is what we think it is. It says that. Okay, so I found out the issue, and it turns out that I misread my notes, and we also need to wrap this file URL to this import.meta.url and another function called file URL to path. And that's just a little bit of formatting because this import.meta.url doesn't give you the actual path of the file directly. It gives you some kind of special string, and we need to parse that special string using this. And we can add import from URL. Great. And then when we run it again, yeah, it gives us this big, huge JSON where, let me make this a little bit easier to read. So it gives us these two things, modules and dependencies and digest. We don't really care about the digest at the moment. We do care about, we want to get this modules, we want to get this array that contains the bytecode and this array that contains the dependencies, and we want to get that into a object in JavaScript. So we can do that by running by object destructuring. We can do dependencies and modules. So now that we have the bytecode and we have the dependencies that we need to actually run the command, or we need to actually run the RPC request that's going to deploy this to chain. So let's just make a, just for debugging, let's do console.log. Just say, oh hey, we successfully, let's make a console log that says that we are building contracts, and then here's another console log that says that we are deploying contracts. And for this, we're going to use something called a programmable transaction block, or PTB. And another thing, actually, before I do that, another thing that we might care about is which address we're deploying from. Just so we know, just make it a little bit prettier. Deploying from, use this templating syntax again. Pulling from, and we can get the current address from this key pair dot address to SWI address. So we're going to use something called a programmable transaction block, and this is a really important part of SWI that's is definitely the recommended way, and I think the only way to make RPC requests. I think all the SDKs use programmable transaction blocks. Or at least not to make RPC requests, but to make move calls and to actually interact with the chain. And the way it works is that, unlike in Solidity, right? In Solidity, when you make a transaction in Ethereum, all you do is say, hey, I want to, there's this particular contract address, and I want to call the function with this signature and with this parameters. And you can't do things like, let's say that one pattern that you really want to do is in ERC20 you want to approve a transaction, and then you want to perform the transaction that requires approval, and you can't really do that very easily. That's something that requires two transactions. But with PTB you can do it all in one, and the way that it works is PTB is you can kind of mix and match whatever transactions you want to call. You still have to follow the rules of move. So if there's like an object that doesn't have drop, then you can't drop it. But the great thing is that the entire transaction, the entire PTB goes through, it's either all at once or nothing. So we're going to create a transaction block called deploy trx, and that's going to be a new transaction block. And yeah, great. So it's instead of, I don't like the path. Instead of doing it like that, because it looks like something's wrong with my LSP, it's not able to correctly detect where to import it from. So we're gonna import transaction block from Mistin SweJS transactions. And then we're going to do deploy trx.publish and give it the modules dependencies. And we also have this upgrade cap. I prefer to use snake case. And what this is saying is that we have this transaction block, and the first thing that we want to do in this transaction block is we want to publish. And whenever you publish something, this is like a deploy, you get back this upgrade cap, and this is what allows you to do upgrades in SweetMove. And upgrades are a way of replacing contract code. It's kind of similar to the proxy pattern. There's certain things you can do, certain things you can't do. But the most important thing is that somebody needs to own this upgrade cap. And so we're going to transfer this to ourselves. By default, in a programmable transaction block, if you have some piece of code that creates an object, it doesn't automatically give it to you. You have to then call the transfer, the native move transfer that I was talking about earlier, to transfer it to yourself. And then deploy trx dot transfer objects. That's what's going to do it for us. Put the upgrade cap in there, and then deploy trx dot pure key pair dot to sweet address. So right here, you can think of this transfer objects as like a native move function that requires certain objects and like this other argument. So these are two arguments that requires. Whenever you're putting in, like, let's say a string or an integer or like a boolean into as a parameter into a move call, you need to wrap it with this .pure. Otherwise, if it's an object, you wrap it with deploy trx.object. And this is just like a regular, this to_sweet address is just a regular string. So it'll convert the regular JavaScript string into the format that Sweet expects. And then this is so this deploy trx now is all we need to do to publish. And the way that we actually run it is we do await client dot sign and execute transaction block. We're going to give it the signer, which is the key pair. We're going to give it the transaction block, which is this deploy trx that we just made. And then we're going to give it some options. You can play around with this and see what they do. For demonstration purposes, I'm going to set this to be true, show effects to be true, show events to be true. We want show input actually to be false, so we already know what the input is. Show object changes. This is important. You actually do want this to be true. Otherwise, it won't. It's going to give us back JSON that says, hey, like what objects were created and which objects were modified on chain, and that's what we're going to use to get this into a format that the front end can. We actually need to parse the package ID like hexadecimal to so that we can use it in our front end later. And so this needs to be true for that to show up in the JSON return. And finally, we're going to do show raw input. We're going to set that to be false. And it's going to give us some JSON similar to what we did with dependencies and modules. We're going to destructure that, and the two things that we care about are object changes and balance changes. Oh, and I guess if you want this balance changes, it's not completely necessary. Like, you could write a deploy script without it, but we're going to use it. And if you are using it, this needs to be true. And let's also, so let's just see what this does. Console.log. Object changes, balance changes. And you're going to want to make sure that whatever wallet is associated with this public key has a certain amount of DevNet tokens in it, because running these transactions is actually going to cost money. And then we do npm run deploy. It didn't work because it says that we have no valid gas coins. Sui client gas. Yeah, so it looks like Oh, I think this is a potentially a good thing actually, because it's a good demonstration. What I noticed that in between when I was recording the tutorials, the chain actually was updated. So we go to sweescan.xyz, see the devnet. Yeah, so if you ever look on Sweescan and you look at it, might say stopped here, right? There might be a little red icon that says stopped, and usually that happens because they're upgrading the chain to different versions. And right now, I think they do that about like every month or so. And on DevNet, what that does is it resets the entire chain. So that's like we got gas before on previous tutorials, but now we don't have any gas. So we can fix that just by going to, again, back to our wallet and getting more gas. Another thing that's important to know is that, once we connect glass, yeah, there we go. So another thing important to know is that we have this warning where the client-server API version mismatch is there. This CLI requires, or it doesn't require, but expects a certain like chain version. And so right now it says, oh, the server API version is on 1.10, which is the chain version of what it really is, and then but our CLI thinks it's 1.9, right? So that's a problem. And at the moment, there isn't really a great way of fixing this. What you have to do is you have to just completely reinstall the SWE CLI. In that case, all you have to do is just run that last command that does like the cargo install from the SWE CLI GitHub, and then this will re-download it. It'll take 30 minutes again, which is annoying, but it works. So I'm actually going to go ahead and pause here. I'm going to go do that, and I will be back very, very soon. Alright, and we're back. I just reinstalled my SWE, so now I'm in version 1.10.0, and we should not run into that issue anymore. Now if I do npm run command, npm run deploy, build the contracts, and then it'll deploy the contracts, and it will properly get the gas token, and there won't be that error message with when I do SWE coin, or SWE client SWE client gas. Yeah, we don't have this warning that shows up. So now if we look at the object changes and balance changes, we see that, yeah, let me make this big again, is that it's a big list of changes, right? These objects represent a mutation or a creation of a particular object. So the first mutation, the type, means that it's mutated, so either an existing object was changed, or, and with this one, when it's created, they created a new object. The sender is the wallet that signed the transaction, that initiated the transaction, and the owner is who actually owns the object. We also have the object type. Notice this is a really important concept to know. Sometimes in the SDK they'll expect a type that looks like this. Like when you're calling a function, it'll expect the fully qualified name, and this is what that looks like. Is you have since this is this coin, this is on the standard library, and the standard library, or at least, well, so there's the SWE standard library, which is OX2, and then the move standard library for stuff like vector, which is OX1. Coin is on the move standard library, so it's OX2 coin. This is what the module is called, and this would be what the type's called. And then this is the parameters, which are also fully qualified. Object ID, version, previous version, and digest, that have to do with, we're not going to go in depth to what exactly those mean. I recommend looking at the docs for a more in-depth explanation, but they aren't going to be relevant for what we're trying to do. And we have this big list of all of the changes and mutations and creations that were associated. We also have this type published with the package ID. So this is the package that we just published to chain. And if we in fact go back to our sweescan.xyz, we can paste this in and see if it has it. Yes, it does. And I just want to point out, yeah, so this has the decoded or the decompiled bytecode. So now we can see the make row, make quadrant pixels in it. Yeah, we can see all these. We can see all of these, all of the bytecode and all the functions that we previously created. So let's go ahead and, just as a starter exercise, let's just print out like a formatted version of how much gas. Like we just want to have the deploy script tell us how much gas we displayed. So So first thing to notice is that this balance change might possibly be null or undefined, and we're going to use the same trick, where if not balance changes, so if it's undefined or null, we're going to console.log. We're going to say error no, we'll say balance changes was undefined, and then we're going to process.exit with error code 1. And once again, we can see that after we type this, balance changes will be, the type of this is the balance change, an array of balance changes. And we want the first balance change. So if we go back up to here, you see it's just going to be an array with one item. We get the first item of that array, and it's the struct, and then from that we go amount. This is going to be the string. I'm going to write, and also just for an example, I'm going to write a function that formats this value, this string, to be a like a number of how many coins with 9 decimals. And we can write a function like that, like const. Actually, I'm not going to use const. Function parse amount, and this takes a string, so amount as a string, and it returns a number. And we can write this function, and of course, syntax error. We can write this function as, so first we want to do is we want to parse this, we have the string, we want it to be a number, so we want to parse it into a number. Parse int amount. But the problem is that this at the moment is an integer, and so we need a decimal. So then we can divide this by 1 followed by 9 decimals, or 1 billion. And that's going to give us 6 as a fraction. But actually it's going to be -6. In this example, it's going to be formatted as a negative. So I guess this is fine for a helper function, and we want to return that. And we want to print, but when it actually comes time to print it, I think we probably want to throw in an absolute value, so that's +6, right? Because we're spending +6 tokens. So we can do console.log spent. Once again, make it a template string. Spent math.abs parse amount number, and remember balance changes 0.amount, and we spent that on deploy. And that's actually a lot of sweet. In fact, if you go here, I don't know if you could tell, but before I hit refresh, the max gas fee was like, a fraction of a SWE, and then we just updated it to 6 SWE. So at the moment, we just made the most expensive in terms of gas transaction on DevNet, at least on this version of the chain. And I had the record too on the previous version of chain when I was writing the testing code for this. So this is not normal. Do not expect to spend 6 SWE. It's just because we're putting so much data on chain. We're putting 16,000 pixels on chain. It's a lot of pixels. It's a lot of data. It's a lot of U32s. So your deploy cost is going to be a lot lower if you're writing any other kind of application. So we spent that on deploy. Let's also do the same thing that we did up here for balance changes, because we're going to use object changes pretty soon. Do the same thing. Object changes. Whoops. Object. So now recall how we had this object, object changes. It's just a big list of all these different object changes, and there's one thing that we want, and we want the package ID, right? So in this big list, it's going to say, hey, you published a package, and that's going to have a certain package ID and a certain version and a certain digest. But what we really care about is package ID, right? Because we're gonna need this package ID later when it comes time to deploy, and we want to tell people, what's the ID of our package, right? That's really important. So in order to do that, we're going to take the object changes, and then we're going to do find. And this is a function that takes a predicate and returns the first. It's on this array, and it takes a predicate, and it returns the first item of this array that is where this predicate returns true. So like say this is a change, so we want the change dot type to be equal to published, and this is going to say const published change, and this is going to get us the change associated with the published. And again, we're gonna verify this, and we're gonna validate this and make sure it's not undefined. So we're gonna do if published change dot type not equals created, not created, published, then console log error did not find correct published change. And we're gonna do and then exit again, exit 1. And instead of, the reason why we're doing this is because in TypeScript, this syntax is like it's called nullish coalescing operator. So what we're doing is this public change, it could be undefined. So in the case that it is undefined, accessing this property type on it is going to return undefined. And it just, like, if we could do another one of these and, you know, access some other method, and then if it kind of goes down the chain, and if anything is undefined, the whole thing is going to be undefined. So in the case that this is undefined, this is going to be undefined, therefore it's not equal to the published. But what if it is defined? Then it's going to be sweet object change, and then the type is going to be either published, transferred, mutated, deleted, wrapped, or create. And we want to make sure that it's published. And if it's not published, then we'll exit. And the reason why we have to do this is because when you use the .find, like we know, right, this change.type is published because we, like, calling this method ensures that, so we have that guarantee. But the problem is the compiler doesn't know that. And so if we make the check in this type of way, now if we go to publish change, we can actually get the package ID. Whereas if we just checked and see if this was undefined, we would have to, like, make sure that the type of published change is published again, and we can just do this in all in one step. So this is going to be the package ID. It's a string, and now it's time to integrate this and get this in a format that the front end can see. So we're going to do deployed addresses. We're going to create this map, or this object, and the keys of this are going to be, like, for example, package ID, and this is going to be the published.package ID. And the way that this is going to work is we're going to modify this, and eventually we're going to do more modifications because there's more object IDs that we care about. We need to get all the quadrants still. But let's skip ahead a little bit, and let's write the code that connects this with the front end. And what we're going to do for that is we're going to use this API provided by Node called write file sync from FS. And what that does is it takes a file, or it takes a path, and it's going to write some, like, string to that file. And the path that we want, so we're going to call this deployed path, and this is going to be path.join. We're going to do the same trick again with the dir name. And so yeah, let's actually take some time to abstract this out, because it's good, you know, software engineering to abstract things that you're using over and over again. So we're going to call this this variable. We want a path to the path2 scripts folder, and we're going to copy what we did already with this dir name. So copy, and we're going to replace path to scripts. And then again, we can use this. We don't have to type out that long thing. We do path to scripts, and so our scripts are right here. So we want to go back one, and then we want to go forward into a file, and that's where the JSON file is going to be. So we want to go ... / and then we do source, and go into this go into the source folder, and then we want the JSON file that contains all the addresses to be in the source folder. Source folder / deployed objects.json. And then when write file sync, what we do is we give it that path, deployed path, actually, let's rename this. This doesn't make any sense. So, actually, that's a fine header. That's a fine name. But what we're going to write to it is we give it a string. So we're going to stringify this object deployed address, and we're also going to give it some other options. And what these other options do is it makes the JSON like pretty print. Actually, doesn't. This is not boundary. This is for. So what this for means, this null is it's. Don't worry about this null, but what this for is it's saying that you want to indent with 4 spaces, and that's going to make it look pretty and not like just big unreadable mess. So let's run this and see what this does. Oh, not SweetClient guys. Let's run npm run deploy. And the reason why we're getting this error is because, as I previously mentioned, like we're using 6 gas to deploy, which is a lot. Normally you don't need anywhere close to that. So what we're going to do is we're just going to hit the faucet again. And I'm actually going to, after this, I'm going to hit the faucet quite a few times because we're going to be doing a lot of deploys. And that's why we're running into this. And I guess while we're waiting, I'm going to, oh, never mind, it works. Yeah, so we spent 6 on deploy. It creates in source, creates this deployed objects.json. It gives us this package ID. We can verify that this works in Sweet Explorer, search it up, and it successfully finds the correct package. And so now let's go over how to actually, we have this package ID in our source, we have this file, and it's actually okay. We want this to be committed to source. You may not want that depending on your setup, but I think that for most full stack apps, I think you do actually want deployed objects to be committed to source. So we have this in our source directory. So how do we actually use it in the React front end? Well, let's just make a simple example to this. This is our app.tsx, and this is where, it's the development server isn't running right now, but this is where this code is associated with this. This is what the code is, or this is the source for this demo example. And I don't really want to make a big whole thing quite yet because we're going to change all this code later. So what you can do in React is you can import this file. You can import the JSON file directly. So we can do deployed packages or deployed objects from /deployed objects.json. And it's possible that this gives you an error. If it does give you an error, it says, oh, I can't import this JSON. There's something that you need to set in tsconfig, and it's this resolve JSON module. So Vite, it looks like that's great. By default, it sets it to true. But if you run into an error like this, you do have to make a setting in your config. But so we have this deployed objects. We can actually just use it right now. Deployed objects.packageid. And npm, we have to run the dev server again, or otherwise it won't. This page won't update. And yeah, so now this shows that we have our package ID. So and you can use this as just like a regular deployed objects.package ID. This is just a regular string that you can use in React. And so that's how we're going to be connecting. React to actually, so it actually knows what our deployed packages are. We're going to be collecting all the relevant objects in this deployed objects.json. And then we are going to be committing that to source, and then the front end can just import this. And as long as it's at the same format, it doesn't matter if you overwrite deployed objects.json. So if you think back to what my architecture discussion is unfortunately this package ID is not enough to get the current board state. And remember why is because we're storing the board in these 4 quadrants. So if we go back to place.move, we had these 2 structs, this place and quadrant, and all the boards are stored in, in this quadrant struct, and we have 4 of them. They're floating around, and they were created successfully on init. Remember, because that's when we were creating them. So they do exist, but we don't have their IDs in deployed objects.json. And also recall that in order to call the set pixel app function, you need the object ID of place. So we're going to need to find those 2 things and put them in deployed objects.json. So let's go back to our deploy script, and I'm actually going to, this is also another really useful trick. You can have 2 terminals running if you guys code at the same time, which makes it pretty easy. And I'm going to console.log out the object changes. And the reason why I'm doing this is to illustrate that the way that we get this object ID is we look through this big list of object changes. So I'm looking, I don't quite see it. We're looking for this, we're looking for this object type. So here's one of them. So we see object type has, this is our package ID for this deploy. It's on place. So this is the fully qualified name of the quadrant type. So this is one of the 4 objects that we're getting. So what we need to do is we need to look through, or one way that you might think about approaching it is we need to look through this list and filter out all of these structs that have the object type that are equal to this, and then we can collect the object, and then we can collect the object IDs, and then that'd be fine. The problem with that approach is that unfortunately in this list, and this personally, this is a change that I'd really hope that they would make, because it'd make this step a lot easier. But at the moment, these do not have a consistent order, and the problem that comes into is we need an ordering. We need to know which quadrant is which when it comes time to like display and update pixels. Right? That's a big problem. Because if it's not in list, we might think that this quadrant is quadrant 3, and then we get the wrong pixels, and this quadrant is quadrant 2, and then it's just bad. And we can't do it. There's really no way of doing it just from this, because of that lack of order. So we're going to solve that in a second. But one thing that we do need to get, we do still need to get the place. So I'm going to look through again, and we see, so this is the object ID that we care about, right? It has the package ID, place. This is the right type. There's only one of these objects, so the ordering doesn't matter. And again, in your application, you're probably not going to need to deal with a specific ordering in the same way that I am, so you're not going to run into that problem. But what we need to do here is we need to get this object ID, and we need to store it in deployed objects.json. And we can't just copy paste this into code, because this package ID is going to be different every single time. So I'm going to write a function that I personally feel like is very useful, and that is this find one by type function. So we're gonna say function find one by type. We're gonna give it the changes. So we're gonna say changes SWE object change, and we're gonna import that. In my IDE, just pressing enter imports the SWE object change. So you're gonna want to do that a little bit differently. And again, this is an array. You're gonna want to do it differently if you're using like a different IDE. Type, and we want to give it this object type to filter by, and this is just going to be a string. And so first is we're going to find the const object change. We want to do a similar thing we did here, where we do object changes dot filter change dot type equals created. So this double ampersand here, this is the short-circuiting AND operator. So what it's going to be is if this is true, then it's going to return true, and then if this is false, it's going to return whatever this is. So we just want to make sure that it's, and what that lets us to do is TypeScript is intelligent enough to know that some of these, like the change.type, could be created, or it could also be published. Yeah, and if we look at the package ID here, if it's a type of published, it doesn't have this change.object type. It doesn't have this .object type field. So TypeScript can't let us access that unless we do this nullish coalescing thing, or not nullish coalescing, short-circuiting ampersand. So that's an important pattern. Again, I'm not going to get too deep into JavaScript, but I would recommend looking into this if you're not entirely sure what I'm talking about. I want to make sure that's correct. So this object change filter, and actually it's not filter that we want, it's not find, because we want the first one that exists, because we are assuming this function assumes that there's only one of them in the big list. And if object change dot type equals created, then return object change dot object ID. And the result of this is that this is going to be a function where we give it this list of object change the RPC gave us, and we also get the specific type that we want to filter by, and it gives us either the object ID if it found it, or otherwise undefined, which is totally okay for our purposes. And you may want to write like a more robust function, but this is what I am using at the moment. And what that lets us do is recall that the object type that we were interested in is, so we like const quadrant type equals, we have the deployed address dot package ID, we have double colon, we have the module name, and then we have quadrant, or not quadrant, excuse me, we have place. That's what we're looking for. And then we do const, not quadrant, we do place type, const place, and then we actually look for it by calling function, find one by type, object changes, and then we place type. And if this doesn't exist, again, we want this to fail. And now we have a guarantee that place is, oh yeah, because we didn't. And now we have this guarantee that place is going to be the object ID. Actually, let me change the name so it makes more sense. The deployed address dot, and we're gonna set this to any, as any. Actually, no, we're going to do it like this. Because if we don't do this, it's going to assume that we mean an object literal with this specific key, and it won't let us add new keys. So deployed address, and we want it to be place ID, set that to equal place ID. And after deploying it, we look at deployed objects. Yeah, we now have the place ID. And again, double check this, go back to Sweet Explorer, paste it in. It is an object. Did we get the correct object? I believe we did. Yeah, type, place, place. And it even tells us dynamic fields. Oh, I think this might even be new in the SweetScan. I haven't seen this before. Yeah, it looks like it even tells us what dynamic fields are associated with it. And the next step is we need to get these 4 IDs inside of this deployed object.json. Because when it comes time to actually do the RPC calls that sync whatever the object is on chain to the React, if we just do place, that's not enough. We have to do 4 separate syncs to each of the dynamic fields. And again, this is a constraint because we need to get rid of the object limit. We need to get over the max kilobyte size limit. And that's where this function comes in. Again, right, remember we don't have that order on deployed objects on the object changes list, so we have to resort to some kind of on-chain code. And I think anyway, this is a pretty good example of how to do reads on on Sweet. So get quadrants. This is a function, right? What we want is we want place, and then we want to get all the dynamic fields, and then we want to just give back a vector of the addresses of those dynamic fields. So we have let addresses equals vector empty address. Iterate from 0 to 3. We're actually going to do it like this. Let I equals 0, while 4 I equals I plus 1. Look up quadrant, and again we're using this dynamic object field, so we're going to copy paste this. So I do less typing. But instead of borrow mute, because we don't need to mutate it, we're just reading, just do borrow. And actually, now that I think about it, since we're not mutating this at all, this doesn't need to be an ampersand mute. This can just be an ampersand place. And this doesn't need. And yeah, we get this error. Add the semicolon. It's telling us, yeah, we're giving it an owned UID, but it wants a reference UID. And quadrant ID also incorrect. We want this to be a U8. And so now that we have this quadrant, we want to get the address, it's a field associated with the UID. So UID is basically just a struct that contains the address, that like the object ID address, and we need to like unwrap that from the place.id or from the quadrant.id. Quadrant. So we're going to do let quadrant address equals, and we're going to use this. We're going to use the function on object. So besides the new, we're going to also import this UID to address. UID to address. Set this to be quadrant.id. And then we're going to, well, it gives us an error first. Probably the same situation where it needs a ampersand. It needs to take it by reference rather than by value. And then we do vector push back mute addresses quadrant address. So we've just written a function that takes in the place and goes down the list of quadrants and returns the addresses to those, which is exactly what we need. This is what's going to give us a constant ordering in our deploy script. And so in order to interface with that, we're going to have to make a call to the function that we just deployed on chain. And we're going to do that with another programmable transaction block. So we're going to do const read, we're going to call it quadrant TRX equals new transaction block, and then we need to do a move call, which is going to call into a function rather than deploy a package. And that takes two things that are important here. Target, and we're going to have to make a fully qualified name here like I was talking about earlier, where it is, we do the package ID. I'm going to, because I'm going to use the package ID more often, I'm just going to assign this to a variable. Const package ID. Package ID, 2 colons, we called it, what did we call it? We called it, place. And then this is going to be quadrant. Or it's not going to be quadrant, it's going to be the function name. And we named the function get quadrants. Then, because this function takes one argument, it takes the ID of place, we're going to pass in those arguments, and this is going to be an array. And we use this object function on the quadrant TRX, and this is the place ID. So place ID. So a couple of nuances here. Because we're putting in object IDs rather than just pure values like U8s, we're going to use this object instead of pure. So this is the same if you're using like a shared or a frozen or something, just any kind of object ID, you're going to want to use it on this. The other thing to note is that we have 2 of these transaction blocks floating around, and it's really important that you use the object method on the right quadrant transaction blocks. So keep this consistent. If I were to use this deploy TRX variable, like if I were to call deploy TRX.object, it wouldn't work. It needs to be the same. It needs to be the same value variable here. And then we need to sign this transaction, put it on, and actually read the results. So we do that with, well, first, it's always good to console log so you know what you're doing when it comes time to debug. Getting addresses of quadrants, and then we do const read result So this dev inspect transaction block is also really important. This is similar to calling a read-only method in like the Ethereum RPC. What this does is runs it into dev inspect mode, which means that you can call for any transaction, any kind of transaction block, and you can even, I believe you can even like fake addresses. Like you can say, oh, I want to pretend as if I'm calling this, and pretend this is a valid transaction from this address. And it just tells you, it tells you what happened. Like it'll give you back object changes, and you can see the results of the move function you called, which is what we care about. But beyond that, it's never actually going to mutate the chain. It's never going to make any kind of noticeable effects on chain. And this takes two things. It takes the sender, which is required, which we get from key pair .tc address. It also takes the transaction block that we just made, which is quadrant. Which is quadrant TRX. So let's go ahead and console log this, which will make it easier to parse and see what's going on here. So yeah, we can see the results. So the return values that we care about are going to be in this results array. And we're going to do this again. We're going to go read result dot results, and we care about the first thing here, and it has these return values. And we're giving an error because this is all potentially null. So we want it to work like this. Const return values. And once again, this can be undefined. So if not return values, error. Yeah, let's see what this updates. Run it again. So note that in this return value, we get this really weird array. Like, what is this? Like, this is just a bunch of numbers. Like, what does this mean? It says, we also have this thing that says, oh, it's a vector address, right? Like, what is that? What does this all mean? How do we get from this number to what we care about? Well, this is the binary serialization format of this type. So vector address, the way that this is serialized is you have the first byte be the length of the array and write 4 quadrants, so there's going to be 4, and we have 32 bytes for each of the addresses. So that's going to come out to it's going to be 133 bytes because we have 32 times 4 plus 1 that stores the length. And so you could actually, what I was doing previously is you could actually just write your own parser to convert these all to bytes, concatenate them together, chunk them, and then put it into a list of addresses. But fortunately, this is really cool. Fortunately, there exists this BCS. Yeah, BCS and it gets imported right here. Yeah, so this BCS variable that SWE exports. So that way we don't have to write our own parsing code, and that's going to be, make things a lot easier. And so now that we have this list of return values, we want to get this big array of numbers, and we're going to do that with .0. So that's going to get us to this object, and then now we want to get to this array. So we do it again. And and so we're going to use, in order to deserialize this, before I was just writing my own deserializer and doing like bytecode stuff by myself, and that's really rough. I would recommend using like the SDK has a tool that'll do it for you, and that's with this BCS. And what you can do is you can do bcs.d, stands for deserialize, give it the type. Right now this is a vector of addresses. And it expects a values. If we just give it like this, it wants a number, but in reality we have a uint array, so we can do new uint or 8 array. And this is going to give us addresses. And this is going to give us what we're looking for. Yep. These are the 4 addresses of the quadrants. And also in the correct order. And now all that we need to do is set the... we want to include this in the deployed objects. So go deployed objects, deployed address dot quadrants equals addresses. Let's do this. Where's the quadrants? And now after we deploy this and wait a little bit, we're going to see that this is going to update with quadrants, and we're going to have all of our 4 quadrants. And just update. Yeah, there we go. So these are our 4 quadrants. Another nuance is that you notice that here there's no 0x, here there's a 0x. I would say that, to be honest, it doesn't really matter, because usually the SDK can accept either format, but we're just going to make it consistent, and we're going to add that using a map function. So we have address 0x plus address. And it's in order to avoid a TypeScript error, since we know this address is going to be a string, we'll just say that, hey, this is a string. So that's about enough for one video. In this video, we went through actually making the contract. We also did the deploy script and started the front end, and we have a very basic integration between our deployed contracts and our front end. So stick around for the next video. We're going to be going over how to actually do anything interesting. We're going to be going over like how to make the front end, how to implement object caching, and how to actually finally have a real working full stack application on SweetMove. Thanks for watching.